morning. Today we are going to see very important topic in electrostatics called Gauss Law. Okay, and we are going to see its proof also. Before going to see Gauss Law, we have to understand what is meant by flux. What is meant by flux? Okay, flux or simply electric flux also we can say. Okay, for that already we have seen what is a charge and how the electric lines are drawn for a particular charge. This is a positive charge. Okay, therefore electric lines are outward. If you draw negative, electric lines are inward. Okay, now see here the electric lines are outward and depends upon the charge magnitude. The intensity will be more or less. Okay, and you know the electric intensity is more near the charge and the electric intensity will be less when you move away from the charge. And you know the formula also, E is proportional to or E is inversely proportional to R squared. Okay, this is the electric field intensity and you know how it varies. Already we have derived this formula also. Now we have to see what is flux. See, consider one area, rectangle area. Okay, that means this type of area. Now I am placing this rectangle here near the charge. Now how many lines are there? 1, 2, 3, 4 lines are there. 4 lines are in this rectangle area. Okay, and the same rectangle is placed here. Okay, that means that area is placed at B. Now see how many lines are there? Only 2 lines. If you place here 2 lines. If you place here 3 lines may be there. Therefore depends upon the position or place of this rectangle, number of lines may increase or decrease. Okay. Now electric flux, how can we define is number of electric lines contained in particular area is called electric flux. Okay, electric flux means number of electric lines contained in that area. Okay, that means it depends upon electric intensity. That means near means electric intensity is more, far away means electric intensity is less, and moreover it depends upon the area also. If this area is small, number of lines will be less. If this area is bigger, then number of lines will be more. Therefore the flux depends upon electric field intensity and area. Okay, and it depends upon the position also, how we place the area. Okay, if you place like this or if you place like this, if you place like this. Okay, therefore we relate electric intensity and area by this formula. Now electric flux is denoted by the letter phi. Electric flux is denoted by the letter phi. And usually what we do, we calculate for small flux. After that we go for a integration or summation. Now del phi is a small electric flux and which is equal to electric field intensity into del S cos theta, where del S is the area, okay, small area of this point or this area. Now see, I have drawn separately. Okay, this is the all the black lines or electric field lines. It is a uniform electric field I have drawn. Okay, and pointing in this direction. Okay, and this red is, okay, it is an area, and the area of this is del S. Okay, now this n is the unit vector. It is along the electric field line. Okay, I have drawn 3 positions. Now see here, the electric field lines are same, but our area of the element is parallel to this. Okay, now you see the unit vector direction. Now see this, it is inclined with some angle. Okay, it is inclined with some angle. Now we have to put some theta here. Okay, that means here also we can put theta. That means the electric field and this area can be related by this formula. Okay, E dot del S cos theta. Okay, depends upon cos theta, we can find out where or how the our specimen element is placed. Okay, how it is placed, whether in this direction or in this direction or particular direction, we can find it. Okay, now this is the formula for flux. Okay, now it is a small flux del phi. If you go for the total flux, usually what we'll do, now if it is the area, if you want to calculate the area, first you find out the area of this, after that you will integrate for the total area of this element. Okay, or you will go for a summation. Just like we have to calculate the small flux, after that we have to take a summation. Therefore, see, this is a small flux and total flux phi equal to integration of okay, E dot ds. Okay, it's a scalar product. Now I have put one circle here. That means this is called surface integration. Okay, surface integration. Okay, that means you are taking entire surface of the element. Okay, you are taking the entire surface of the element. Okay, that means how many electric lines are passing through the particular element. Okay, therefore we have put surface integral of this element only. This is the flux formula. Okay, now we are going to see what is meant by Gauss law. Okay, Gauss law is based on flux. Therefore, I have given explanation for flux. What's meant by flux? Flux means number of electric lines contained in a particular area. Okay. Now we have to go for a Gauss law. Gauss law deals with electric flux only. Gauss law deals with electric flux only. Electric flux phi, okay, is equal to 1 by epsilon times the charge q. This is Gauss law. Okay, Gauss law states that electric flux is equal to 1 by epsilon times the charge enclosed in that particular area. Okay, for example, here this is a charge. Okay, you name the charge by q. Okay, now the field lines are around it. Electric intensity will be around it. Therefore, if you put a circle here, that means you put a sphere. Okay, spherical sphere. Now, the Gauss law states that this is your sphere and the charge is enclosed inside this sphere. Now, if you calculate the flux, then flux is equal to 1 by epsilon times the charge q. Okay, of this area, this sphere. Okay, this is Gauss law. Now we have to prove Gauss law. 1 by epsilon 0, already you know, permittivity of the free space. That means Gauss law is, this is for vacuum. Now you have to prove Gauss law. How to prove this Gauss law? It is very simple derivation. Okay, but it is very important derivation. Say your charge is q. Your charge is q. Consider a small charge, positive charge. Okay. Now assume one spherical sphere around it. Okay. Or you consider a spherical sphere and at the center there is some charge q. Okay. Now this charge is outwards. Radial it is outwards. Now you consider a point P here. Now you consider a point P here. Okay. Now if it is a sphere means you can consider some small element also. You can consider some small element also around this P. Okay. Now this is your small area. I'll denote this as ds. I'll denote this as a ds. Now you can point out the unit vector also. Okay. Now the electric flux phi, okay, phi equals, what is the formula? E into ds. E into ds. Okay. Now E equal to what and ds equal to what? Okay, that is we are going to calculate. And you can put unit vector also. You can put unit vector also. Now E equal to, already you know, E equal to q by 4 pi epsilon 0 r squared. Okay, if r is the radius of this sphere, if r is the radius of the sphere, then q charge is there and 4 pi epsilon 0 r squared. Okay, now you have to substitute here. Okay, this is for d phi. If you put ds mean it is for d phi. Now if you substitute here, d phi equals q by 4 pi epsilon 0 r squared into ds. But we want electric flux for entire area. This is for small area ds. For entire sphere means you have to take the total area, you have to integrate. Then I told you to integrate, what you have to do? You have to put phi. Phi equal to q by 4 pi epsilon 0 r squared surface integral of ds. Okay, that means you are going to calculate the total area, okay, of this sphere. Now we erase this. Total area means here it is same, phi q divided by 4 pi epsilon 0 r squared, and this surface integral ds equal to 4 pi r squared. That means area of the sphere, outer area of the sphere. Now you substitute here. Therefore 4 pi r squared. Now you cancel this 4 pi and 4 pi, r squared and r squared. You get q by epsilon 0. Flux phi equal to q by epsilon 0. This is the proof for the Gauss law. Gauss law already I told you. Gauss law states that electric flux is 1 by epsilon times the charge enclosed in this closed area. Okay. Now the closed area is sphere and the charge enclosed is 5. Therefore, electric flux of this closed area is q by epsilon 0. Okay. This is the proof for Gauss law. Very important than Coulomb's law. Okay. Now the charge electric flux for outside is 0. That is you have to understand. Gauss law is applicable for some area in which some charge is enclosed. If here you are calculating electric flux means then it is 0. Okay. This is very important concept and we are going to do some more application for the Gauss law. Thank you. Please subscribe and put a comment and please share it on.